Hey guys, Joe back at it once again with some OCR FSMQ past papers, and today we are doing the June 2012 examination paper. Now, obviously the learning objective is to analyse a past paper and see how we will do. If you've missed any of the previous papers that we've done, they're in a playlist on the channel as well as all the lessons that I covered. So without further ado, let's get into things. Number 1. Find the range of values of x satisfying x squared minus 4x plus 3 is less than or equal to 0. So the first thing that you do here is obviously factorise it like that. So it's x minus 3, x minus 1, and then draw your graph. So draw yourself a set of axes, draw the graph, and obviously cut the axes at 1 and 3 according to a solution up here. And then we want to be under the graph because the inequality tells us. Therefore, it must be between 1 and 3. So 1 is less than or equal to x, which is less than or equal to 3. And you've grabbed yourself 3 marks there. Show this range on the number line provided. So it's obviously provided in the answer book. And this is just a higher GCSE question. Yeah, you've got the number line there. And you draw it in like that. Darken it in because it can be equal to as well. Obviously, if it was just not equal to, you would just draw a circle and then the line joining. So that's that. Question 2 then. A die has 6 faces, numbered 1 to 6. The die is biased so that when it is thrown, the probability of obtaining a 6 is 1/5. The dice is thrown 5 times. Find the probability of obtaining at least 1 6. So, first of all, x can be binomially distributed 5, 0.2, because remember it's a fifth, it's not a fair die, it's a biased die, and we've thrown it 5 times. P of x is greater than or equal to 1 is the same as 1 minus p of x equals 0, so it'll be 1 minus 5c0 times 0.2 to the 0 times 0.8 to the rest, which is 1 minus 0.328, which is 0.672. So, not so bad, that one. And 4 marks for this. I think it's an absolute disgrace. It should be the other way around, really. But, yeah, exactly 3 6s. P of x equals 3. 5c3 times 0.2 to the 3 times 0.8 to the 2. And that's 0.0512. So nice easy 4 marks there if you know your binomial distribution. Question 3 then. The function f of x equals x cubed plus ax plus 6 is such that when f of x is divided by x minus 3, the remainder is 12. So the remainder theorem tells us that if we put a 3 through, we'll get a 12 out. So we do that. We'll put a 3 through. We say 3 cubed plus 3a plus 6 equals 12. Rearranging, you get 3a to equal minus 21. Puts a big smile on your face because a must be a minus 7. Trial and error to find a factor. So I'll let x equal 1, 0, minus 1, etc. Just throw numbers through until you get equals 0. And 1 works apparently. So put a 1 through and I get 1 cubed minus 7 1s plus 6 and that equals 0. So therefore, x minus 1 is a factor because, remember, we reverse park it into the brackets. Divide that in. So you ask yourself, what do I times this by to get this? And I say x squared, and I put that on top, and then times throughout. Subtract vertically. Very, very careful because that's a 0x squared there, remember. So it's 0 minus x squared, which is a positive x squared, and then the other two drop down, etc., etc. We've done that in pretty much every past paper so far, so I'm not going to dwell on that too much, but we get 0 at the end, which is confirming what we said up here, so we know we've done it right. And now we've got a quadratic and a factor. We'll stick them next to each other, factorise the other thing, and we're only actually asked to factorise f of x, so we'll just leave it in that form. But x would equal 1, minus 3, and 2 if it told us to solve it. Question 4 then. A car moves from rest with constant acceleration on a straight road. When the car passes a point A, it is travelling at 10 meters per second. And when it passes a point B, further along the road, it's travelling at 16 meters per second. The car takes 10 seconds to travel from A to B. So, we need the acceleration first, I mean, you could work out the distance if you wanted to, but I'm going to work out acceleration. So we'll list our variables. We'll want the distance, we'll want the acceleration, so we'll put question marks under them. We're told that it initially starts at rest, but when it passes a point A, it's at 10, and because it's going from A to B, that is what we use as our initial speed. And the final point B is when it's travelling at 16, so that's our final velocity, and 10 seconds to travel from A to B. So that's a bit of a trick. A bit of a trick the examiner's played. Most people would have probably put u equals 0. But v equals u plus at, dump in the numbers, rearrange, and you get a to equal 3/5 meters per second squared, or 0.6. And then I can put that back in to s equals ut plus a half at squared. Any formula you want to use for your distance. Put in the numbers, and you end up with that, which is 130 meters, so not too bad. There. Question 5 then. Show that the equation 3 cos squared theta equals sin theta plus 1 can be written as 3 sin squared theta plus sin theta minus 2 equals 0. So all I see in this is sins, so I know I need to change this cos somehow into a sin. I know that a cos squared equals 1 minus sin squared, so I can replace that in brackets like that. And then I'm going to expand to get that. 3 minus 3 sin squared theta equals sin theta plus 1, and rearrange to get it in the examiner's form that he wanted you to, and you've just grabbed yourself 2 marks. So now we've got to solve this equation that satisfies 3 cos squared theta equals sin theta plus 1, but this here looks very, very familiar to this here. So we're actually going to solve this equation here, because the examiner wouldn't have got you to do that for no reason. So we do that. We use the first letter of the trig, and we'll factorise that to get that. And then we'll bring the trig back. So sin theta equals 2/3 or minus 1. Get a calculator involved, and we're going to get 41.8, 138.2 and 270, because if we think about our sine graph, we end up like this. We're going to have the line 0.6 going up here, so we've got that point there, which is 41.8, that point there, which is 138.2, and this point down here is 270, because that's the only place that goes through minus 1. So that's where that comes from. Question 6 then. The equation of the curve y equals 2x cubed minus 9x squared plus 12x. Show that the curve has a stationary point where x equals 2. So to find stationary points, we have to diff it and set it equal to 0. So we do that. I see a common factor of 6 in that equation, so I divide through by 6 and call it x squared minus 3x plus 2. That actually factorises lovely to x minus 2, x minus 1 equals 0. So x must equal 2 or 1, and we were asked to show that one of them is x equals 2. And now we've got to determine whether the stationary value where x equals 2 is a maximum or a minimum. Well, we can tell whether it's a max or a min by diffing it again and then putting my x coordinate through. So we diff it again, and we call it 2x minus 3, and then we'll shove our x coordinate through, and then we'll say when x equals 2, the second derivative will be greater than 0, therefore it's a minimum point, because it's the opposite of what you think. If it's positive, it's a minimum point. If it's negative, it's a maximum point. So there we go. Question 7 then. A yachtsman wishes to sail from port A to another port B, which is 9 kilometres due east of A. Because of the wind, he's unable to sail directly east and sails 8 kilometres on a bearing of 070 degrees to the point C. Calculate the distance he is now from port B. Well, first thing we do here is say it's the cosine rule, because we have well, if we have our little right angle, well, triangle here, we can call this 20, which is what I've done down here, and then we'll call that 8, we'll call that 9, and we now want this line here. So we want CB. Right, so CB squared equals 8 squared plus 9 squared minus 289 cos 20, cosine rule. You are actually given it in an exam, it's one of the few that you are given. Put that into your calculator, so CB squared equals 9.68, so therefore CB equals 3.11 kilometres. Now then, the angle ABC, that's what we're finding, and hence the bearing on which he must sail to reach port B from point C, correct to the nearest degree. So it's the sine rule for this one. So you've got sine x over 8 is equal to sin 20 over 3.11, because ABC is this angle here, and we've got opposite buddies together, so like that. So ABC must equal 61.6 degrees, but that's not the nice part of this question. So there's 61.6. We also want the bearing from C, so if we put ourselves a due north in there, and then we'll spot the right angle triangle, that's going right down the middle of it like that. So I'm just going to put a little box here. We want this angle, which is that little drawn round the outside there, like that. This angle there must be 70, because obviously 20 add 90 is 110, and 180 degrees in a triangle, so I've inferred that this is 70. There you go, I've just put it over. That angle there, therefore, must be 180 minus 20 minus 61.6 minus 70, because obviously it's this angle here. 180 degrees in a triangle, we've got 20, we've got 61.6, so that's 81.6, got another 70, so that's going to be 151.6, so it's going to be 28.4 degrees. So that's that angle there. But the bearing will be 180 minus your 28.4, because angles on a straight line add up to 180, and we want this angle here. So it's 180 minus 28.4, and that is going to be 151.6. Sorry about that, the recording just cut out, you might not have noticed it, but hey ho. So there you go, the bearing 151.6 degrees. Question 8. Show that the integral between 2 and 0 of x squared plus 2x minus 3 equals 2/3. So, when we integrate between limits, we add 1 to the power divided by the new power, and then we'll stick with 2 in, stick with 0 in, take them off each other, end up with that, which is 2/3. So, you've just shown that is the definite integral of that. But the diagram shows part of the curve, x squared plus 2x minus 3, and Mark claims that the total area between the curve, the x-axis, and the lines x equals 0 and x equals 2 is 2/3. Explain why he's wrong. Well, if there's a crossing of the x-axis, we can't actually do it in one go, if you remember in the lesson. If the curve crosses the x-axis, then we can't do it all in one go. What we have to do is split the integrals, but we'll put up goalposts like that between 0 and 2, and then we need to put in an artificial goalpost at x equals 1, because that's where it crosses the axes. Then we'll split with integrals into between 2 and 1, and then minus between 1 and 0. So it's the same again, add 1 to the power divided by the new power, put the 2 in, put the 1 in, take them off each other, put the 1 in, put the 0 in, take them off each other, you end up with that, which is 12 over 3, which is 4 units squared. So quite a nasty little question, that one, but hold your nerve and you should be fine. Question 9 then. The height above the ground of a seat on a fairground big wheel is h meters. At time t minutes after the wheel starts, h is given by h equals 7 minus 5 cos 480t degrees. Write down the initial height above the ground of the seat when t equals 0. Now that's a big gift from the exam, they're telling you that initial means when t equals 0, because they could have easily just said initial height and you'd have to infer that, but you've literally got no more work to do here really. Just let t be 0 and you get that. Cos of 0 is 1, so it's 7 minus 5, which is 2. So there you go. That's the initial height of the seat. Find the greatest height reached by the seat. So the max value of a cos is 1 or minus 1, because if we think about the graph, I'll do it up here. A cos graph runs like that, and it runs between 1 and minus 1. So if we let cos be equal 1, we'll get 2 again, but if we let it equal minus 1, we'll end up with 12. Therefore, the maximum height of the seat is 12 meters. Calculate the time of the first occasion when the seat is 9 meters above the ground. Give your answer correct to the nearest second. So we'll set it equal to 9 with a little equation there. Take people over the other side, so 5 cos 480t must equal minus 2. Divide both sides by 5, you get that. Get your calculator involved, you get that. But remember, that's 480t, we want t on its own. So we'll say 0.236, but remember t is measured in minutes, and we want seconds. So we're going to have to times that by 60, and we end up with 14 seconds. So there you go. Question 9. It's an okay question. Question 10 then. 3 points, A, B and C, given by those coordinates. Find the coordinates of the midpoint M of AC. So average of the x's, average of the y's, 4, 6. Find the equation of the circle with AC as a diameter. So we're going to have to find the length of the line. So the diameter is back take back squared added to front take front squared and then rooted. And that equals 100. Therefore, our radius must be, hold on a second, let's work this out. So that's 8 squared, add 6 squared, which is 100. That should be 50 there. There you go. So put in your numbers, and as you can see, I don't know what I've done here. That should be, hold on. That should be 10, because the root of 100 is 10. So therefore, the radius is 5. Therefore, we'll put our midpoint into the equation. Remember, you reverse park it into the brackets, and then it equals r squared. So r squared, 5 squared, 25. Sorry about the confusion on that one. Show that B lies on this circle. So we'll show that a point on the line by letting x be the number and y be the number. So we'll let x be 8 and y be 9, and then put it in, and that'll equal 16 plus 9, which equals 25, and it equals 25 there and there. Therefore, it's on the outer rim of the circle. Prove that AM and BM are perpendicular. Well, perpendicular lines have negative reciprocal gradients, so if we do back take back over front take front of both of them, we'll end up with that for BM and that for AM, and they are negative reciprocals of each other, therefore they are perpendicular. Part 5 then. BD is a diameter of this circle. Find the coordinates of D. Well, draw yourself a circle. We know that the centre is going to be 4, 6. We know that B is 8, 9. So if we look at the distance there, we know that the point D must be that point there. But if we look at the distance between 8 and 4, that's obviously 4, so I think that's going to be 0, the x-coordinate. Distance between them is 3, so I reckon that is going to be 3 there, just by distances. And it is 0, 3, so there's your answer. So draw yourself a little sketch at the end there. Question 11 then. The shaded region in the diagram shows a wooden shape. The curve has the equation y equals half an x squared, and the coordinates of A are minus 2, 2. The line AB is normal to the curve at the point A. Find the equation of the line AB. Well, normal at A, therefore we have to differentiate. So power to the front, knock 1 off the power, you just end up with x. When x equals minus 2, do y dx equals minus 2. Therefore, the gradient of the normal is going to be a half, because it's the negative reciprocal of the tangent. Y minus b equals mx minus a. Put in your numbers, careful of double negatives, expand, tidy, you end up with that. 2y equals x plus 6. Find the coordinates of the point B where the line AB meets the curve again. So curves meet when their algebra is set equal to each other. So we do that. One singular y, by the way, equals that over here, just divided by 2. I set that equal to that, because where I see one y, I can paste it into the other, so I get that. Times through it by 2 to get that. Quadratic, factorise, and you get x equal 3 or minus 2. We already knew one of them was minus 2, so that confirms what answer. So when x equals 3, y equals 9 over 2, therefore the point is 3, 4.5. Find the shaded area. So that's going to be the integral between 3 and minus 2 of the ceiling to the floor, because remember, where the lines meet are where the goalposts are going to go. They're a little bit out of line there, but never mind. So that's 3, that's minus 2, and because it's all above the axis, we can just do it all in one go. So that's that. Add 1 to the power, divide by the new power, and you get that. So, by the way, the ceiling in this case is the line, and the floor is the curve. So we do this here, take away this here, and we end up with this here. And then integrating, so you add 1 to the power, divide by the new power, put your 3 in, put your 2 in, take them off each other, you end up with that. Keep pretty much everything as fractions, I would, and you end up with 125 over 12, which is, I think, 11 and 1/12, I think, or something like that, because, well, no, it'll be 10 and 5/12 actually. So there you go. Question 12 then. The highway code gives a table of the shortest stopping distances, d feet, for a vehicle travelling at v miles per hour. The formula used for this table is given by d equals av squared plus bv. Two entries in the table are given below. By forming and solving a pair of simultaneous equations in a and b, show that the formula is that. So we are told that 75 is with d. We are told that v squared is 30 squared, which is 900, and then your v here is 30, so it's 75 equals 900a plus 30b. Similarly, it's 240 equals 3600a plus 60b. Make the top one compatible with the second one by timesing both of them by 4. I don't know, by timesing the top one by 4. I actually went to match my a's, as you can see, and now I'm going to take top from bottom, bottom from top, and you get that. 60b equals 60, therefore b is a 1. Put that back through, your a must be a 20th. Therefore, putting that back into the equation, d equals v squared over 20 plus v. Find the difference between the stopping distances for a car travelling at 65 and a car travelling at 70. So we'll let v be a 65, and we'll get that. So d equals 1105 over 4, and we'll let v equal a 70, and we get that. So therefore you get d equal 315. Take them away from each other, and you get 155 over 4, which is 38.75 meters. Many drivers maintain a distance of 50 feet or less when driving on a motorway. Use the formula in part A to find the speed at which the shortest stopping distance is 50 feet. Well, we'll let d equal a 50, and then we'll have a quadratic in v squared, times everything by 20, and you get that. Take people over the other side, and you get that. And I'm not sure that factorizes, so we have to go to the quadratic equation and do that. And then type everything in your calculator, and you'll get 23.2 miles per hour, because you can't have a negative speed, remember. So discard the negative answer. Right then, 13. Find the coefficients a, b, and c in the expansion of that. So here we go. Binomial expansion, or you could do it where you call it that and that. I didn't do binomial expansion, I just did that, which is that. Square the first, square the second, twice the inner product for the second bracket there, and then expand, and you get that. In ascending powers of x, remember, so where a must be a 12, where b must be a 6, and where c must be a 1. So we'll call it like that, 3 marks. The graph of the equation y equals x cubed passes through the points P and Q which have x coordinates 2 and 2 plus h respectively. Show that the gradient of the chord is that. So, if y equals x cubed, then y equals 8 and 2 plus h cubed, because we've been told that's 2 and 2 plus h. So we just cube them up and we get that. Gradient of a line is back take back over front take front. So we do that, which is not what we wanted to show, beg your pardon, which is that. So that's not strictly what you meant to show, but that 2 and that 2 will cancel, so this bit here is what the examiner wanted you to show, but I just went the extra step and did that, but you really should be doing that. Alright, so express that as a quadratic function of h. So I've now got this, I've expanded, and I can see an h in everything, so I can get rid of that, I can get rid of that, and I can get rid of that and call that a 2. So that's that. And that's a quadratic function of h. So as the value of h decreases, the point Q gets closer and closer to the point P on the curve. As h gets closer to 0, the chord PQ gets closer to being the tangent of the curve at P. Deduce the value of the gradient of the tangent at P. Now, if you watch me odds and ends lesson, this is differentiation by first principles. So we say as h tends to 0, m will equal 12. So as h gets so small, it can sort of be forgotten about, and we're just left with the constant, so we say it's 12. Korean uses the same method to deduce the value of the gradient of the tangent at the point 2, 16 on the curve y equals x to the 4. The first 3 lines of our work are given below in the answer booklet. So take P to be the point 2, 16, take Q to be the point 2 plus h to the 4. The gradient of the chord is given by back take back over front take front. So you end up with that, which is what she's got. Remember, 2 plus h to the 4 is just what we had, with an extra 2 plus h on it. So it's that. Expanding, and you get that. So 2 times 8 is 16, so that means your 2 times 8 goes, and your 16 goes, and you end up with that. Now I see an h in everybody here, so I can just cancel that h. Like that. And that is the same line of thing, so forget this bit here. And then you end up with that, which is what I said, with all h's cancelled out. And as h tends to 0, we can forget about it, therefore your gradient will become 32. So that is that question there, probably one of the hardest that's ever been on the FSMQ. Differentiation through first principles, so go and check out the lesson if you don't understand it. And that is that. Only 13 questions on the June 2012 paper, so I hope you guys have found this helpful. Please leave a like if you did. Leave any questions down below in the comments section. And yeah, not long to go now, about a month till the FSMQ exam, so best of luck if you're sitting at this year. But you know, try not to stress yourself out too much. It'll give you a flying start at A level. So thanks for watching, everybody, and goodbye.